The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome to the second of today's webinars from Smart Vision Europe. And in the second webinar, we're talking about analytics for surveys and customer feedback. My name is Jarlath Quinn. I'm an analytics consultant for Smart Vision Europe, and I'm joined online today by my colleague Rachel Clinton. And Rachel will be making sure that everybody's correctly logged in and fielding questions as we're going along. If you haven't joined any of these sessions before, there's a few housekeeping points we'd like to take care of right away. The first is that we do record these sessions so you can listen to them again afterwards. And the second is that we will be using some slideware, and we'll email out a copy of the slides to you after the session is ended. If you think it's particularly relevant for colleagues who are perhaps not able to attend today's session, it may be possible for us to arrange a rerun for it, in which case drop us an email or give us a call afterwards. And with regard to asking questions, well, all the lines are muted, so we ask you to use the chat facility. If we run out of time, we will follow up with you, and obviously you can ask questions afterwards via email or giving us a call anyway. So if you don't know who Smart Vision Europe are, we are a technology provider specializing in advanced analytics. We have a fairly deep experience across many different sectors. But we are a premier accredited partner to IBM SAS and a company called Predictive Solutions, specializing in advanced analytics, data science, predictive analytics, data mining, that type of stuff. We also work with open source technologies such as R, Python, and Spark. And we are veterans of the analytics industry. Each of the team members have at least 15 to 25 years of experience working in advanced analytics. I personally have worked for IBM, SPSS, and SAS in the past as a consultant. Today we're talking about surveys and feedback, customer feedback really. These days, of course, surveys and feedback requests are extremely prevalent. For very few occasions when a week goes by when we are not requested to rate an experience or provide some sort of feedback on a purchase that we've had. And it's interesting that that has started to occur because there are various things which have driven this interest and the increase in companies' appetites for surveys and feedback. First is that it's cheap and it's instant. It's very easy now for companies to do this, very easy for organizations to ask for feedback and to set up surveys. It's pretty straightforward, particularly due to the channels that they can deploy these surveys through. So there's less need for human-powered data entry. You don't need somebody necessarily to take a bunch of surveys and enter them by hand, which was certainly in the days of pre-mobile phone, and certainly a lot of days prior to personal desktops that was the case. Even paper questionnaires can be fairly easily scanned. There's so many different collection channels now. It's not just websites, but the social media, there are apps, there are wall-mounted buttons, there are voice-to-text mechanisms. So, there's a vast number of different ways in which organizations can ask for people's opinions and attitudes. And again, there are a huge variety of tools for the design and analysis of surveys and customer feedback. On the design side, you have companies like SurveyMonkey, and you also have very specialist tools such as Unicom tools for designing complicated international surveys that have multiple modes to them. So there's lots and lots of different ways in which people can get feedback from organizations, and it's fairly cheap and easy to do it. The other things that's driving it is the fact that customers and clients expect to be asked for the attitude. The biggest and fastest growing global brands make something of a virtue of monitoring their feedback, and they like to use it in their advertising. It generates very valuable, even potentially critical data, because customers are actually telling us what they think about something. They're actually able to give us, and very, very quickly gather information about how something is performing or whether there are any problems. And it also adds an important dimension of customer-client insight, in the sense that if you think about CRM systems, which are designed for organizations to attain a degree of customer intimacy, You know, by asking people directly for their own feedback and to complete a questionnaire or survey, you're really adding quite a lot of additional insight to that point. And lastly, there has been an exponential growth in unstructured data. And unstructured data, by that we mean, of course, not numeric data, we mean video, audio, and text-based data. Certainly text-based data. You know, there's a huge amount of sites now where people offer their opinions on various products, services, experience, and media. The other aspect is that, you know, within the realm of big data, data science, and predictive analytics, very often organizations are reliant upon information such as geodemographic or demographic information to make predictions about how customers are going to behave or what they should be offering customers. They also make use of transactional history, even interaction history of how they interact with a organization, how often they visit a website, how often they call or email. And those three typical sources of data can add up to quite rich basis of functionality and quite a rich island of data, if you like, for them to then develop things like customer retention programs, customer loyalty programs, identifying errors or problems, or estimating lifetime value. But perhaps something that they don't always think about is the power of attitudinal data. So when we're looking at things like applications that are designed to attract and acquire customers, to grow their value of customers, cross-sell, upsell, to retain customers, and even to identify risk of failure of systems to operate, failure of availability, failure of assets to perform correctly. Attitudinal data can be very powerful because, of course, it's giving us extra information. It's not just, you know, information such as people's age, education, and gender. They're actually telling us how they're interacting, what they think of a survey, and that can add a very interesting dimension to these big data sort of applications as well. So attitudinal data, we're now starting to see net promoter score and things like that starting to get incorporated into telecommunications customer retention programs, because it allows them to predict well ahead of time whether or not somebody is likely to renew a contract, for example. So we're going to start with a sort of classic situation here of how we would analyze survey or questionnaire-based data, and just look at from the standpoint of how we would uncover relationships, or how we would analyze the data to uncover relationships. And to do this, we're just going to skip out to IBM SPSS Statistics, because that's a pretty classic tool to use for analyzing survey data. And if I open up a data set here, we've got a data set here called employee. It's a very famous data set that's been used many times to demonstrate various statistical routines. It comes with SPSS Statistics, and it's got a nice mix of different data types within it. So when we look at the data types, you can see there's these different symbols across the top here. This indicates that this is a string field. It's a category string field. This indicates that this is a ordinal field. There's a rank order to it. These are continuous fields. So a lot of the sorts of data that you're going to get from questionnaires is going to be of this type. It's going to be category data. Occasionally, you might get some continuous fields like this, where you can actually ask people, you know, how much money do you spend, or how many children do you have, or, you know, how many times do you like to visit, you know, a particular store, or to make use of a good, or even maybe you're able to ask them what their specific age is in the questionnaire rather than age group. So you get this mix of field types. And one of the first things you learn when you're analyzing survey data is to try and, you know, identify the correct procedure to use with the correct field type. So for example here, if I look at each of these rows of data, each row of data here, we've got 474 rows. Each row represents a different person who's an employee of a bank. You can see their current salary. You can see their beginning salary. And you can see here, for example, that we have data that is made up of codes and labels. So this is a very typical SPSS file where you don't actually have verbatim descriptions, but rather you have coded values. This is a This is a sort of throwback to the days when people used to enter data manually. You didn't want to type in male or female. You didn't actually want to type in the word manager or clerical. So you would punch in codes, and the codes had associated labels associated with it. In the same sense, you had field headers, but you also had a variable label. So it would say gender, it would say employment category rather than just job cat here, or it would say current salary or beginning salary. This would often, the variable label will often be the question within the questionnaire itself. And here, if I right click, for example, on one of these and just say descriptive statistics, it looks at the type of field it is, which is this nominal field, this category field. And it says, okay, for a category field of that nature, I'm going to give you a little frequency table here and tell you that 45.6% are female and 54% are male. Whereas if I asked for a non-category field here, continuous field, salary, it's not going to give me a table of percentages. It takes account of the type of field it is and gives me some descriptive statistics telling me that the mean salary is $34,000, the median is $28,000, and so on and so on. So one of the first things we'll often do within a survey is we'll just look at some category data, and we'll use something like a series of frequency tables for that, and they will give us little tables just giving us a count, the percentage breakdown. Where it starts to get interesting is when we start looking at the relationships between categories, such as the relationship between gender here and job cat, or job cat and minority, or job cat and salary, or years of education and gender. It's these binary relationships, sometimes called bivariate analysis, which is quite interesting. So if we go to use a typical workhorse procedure for that, that would be crosstabs. Crosstabs is a command word within SPSS. That's where the term crosstabs comes from. And I can look at the relationship here between, let's say, gender and job category. And if I put employment category in here, I can tell it I want row percentages. So that will tell me the percentage of males and females because gender's in the row. And I can ask for clustered bar charts, and I can click OK at that point. And it goes and squirts out a little crosstab for me onto the output window here, and it tells me that 95% of the females are clerical workers and only 4.6% managers. Of the males, 6.9% were male. Sorry, 60.9% of the males were clerical workers, 10% were custodial, 28% were managers, and that is reflected in the chart at the bottom here. If we wanted to rerun that, we could click on the recall dialog box button here, call the crosstabs dialog back up, and throw in a different variable such as minority classification, click OK, and now it would tell us what percentage of non-minority employees were clerical workers compared to minority employees, and what percentage were managers compared to minority employees, where 21% non-minority employees are managers compared to 3.8% of the minorities. And again, that's reflected in a bar chart. And if we wanted to do a test to see whether or not this was statistically significant, typically we would ask for a chi-square test for this type of thing. And if we click OK here, it runs and gives runs the crosstab again. It gives us a little extra dialog box out the back here, which is chi-square test. You can see here's a Pearson chi-square. And if I right-click the top here and say, what's this? It tells me that this is a significance test level based on an asymptotic distribution of a test statistic. That means estimated, an estimated value, basically. Typically, a value of less than 0.05 is considered significant. And it tells us here that this value here, of course, is it's very small. And it's basically telling us the probability that the two variables are totally unrelated to one another, that employment category and minority classification are totally unrelated. Basically, that minority classification in no way affects your employment category, or vice versa, which of course, employment category can't affect your minority classification, but minority classification can affect your employment category. So we'd assume that, yeah, there is a statistically significant relationship between these two categories. And if we would look at the bar chart down here, we could edit this bar chart and say, well, okay, let's show this as let's say a clustered bar chart, let's say. So I could say, okay, sorry, as a stacked bar chart. I could change it from that to stacked. And then I could say, okay, show me that as a percentage of 100%. It tells me what percentage of people who, yes, are minority classification or clerical workers, both custodial workers. And we could continue to do that. Now, obviously, I can't use salary against gender, for example, here. I can't use that as a crosstab. Instead, I would have to go to a comparison of means here. So I'd say, look, what's a comparison of means? I'd say compare means and minority classification here for gender minority classification by beginning salary, let's say. And I'll put in something like education level in years and click OK. And that gives me a table of means out here. So here's a table of means. So this is telling me females, the average beginning salary 13,000. There are 216 females. The standard deviation is 2,000. Males, average beginning salary is 20,000 or 258 males. Standard deviation 9,000. And then for education level in years, it's 12.3 to 14.43. For non-minorities, the beginning salary average is 17,000, and for minorities, it's 14,000. Education level in years ranges from 13.69 to 12.77. And in fact, we can play around with these tables in here and do something called pivoting. So we can hide the statistics up into one of these little stubs here and then drill down into them. So if I change that to just an N, that effectively becomes a crosstab again. Here's the standard deviation. Here's the mean value. Now, it would be good if I could have the best of both worlds, if I could have this as a continuous field and as a category field. And to do that, I've got a little tool here called visual binning. If I click on visual binning, I can say, show me current salary, or could have said beginning salary, any one of these ones. I'll just use current salary, click continue. And it scans the data and shows me people's current salary. So I'm going to create a new field here. I'm going to call it salary group. I'll call it GRP. And current salary banded will be the name, will be the label for it. And then I can say, okay, I want to slice it into, let's say, 3 equal groups. So I could go to make cut points here and ask it to produce it, put in 2 cut points to slice it into thirds. So you can see here 33.33. Hit apply. It tells me where it's going to slice it. Here you can see this 25,500. That's where it's going to slice it. If I move that up and down, you can see it's taking account of it. Alternatively, if I change this number here and I just round it down to 25,000, because it's probably a rounder number. And this one here, if I just round this to 33,000, it'll come out fairly close. Sorry, come out fairly close to thirds. Not exactly, because I've changed the values. But fairly close to thirds. So I'll just change this to 33,000. And then ask it to make some labels for these. So we have some little labels here. So I can change this to less than or equal to. And this one, instead of 33,001 plus, I can change it to simply over 33,000. That will create some labels for me with the codes 1, 2, and 3 here on the bottom. And I can reverse the scale if I so wish. If I click OK at that point, it says it's going to create one new field, and it bands the field for me. So when you're working with continuous data, you can use, you get the best of both worlds, because you can always create bands from it, which is a salutary lesson, because if we're doing a survey and we're able to ask for an individual value, like how many times do you estimate you visit a store, instead of giving them a range and breaking it into a 3-category range or 4-category range or 5-category range, if we can ask for the individual value, such as people's ages or the number of times they visit or what they think they spend, if we can ask for it, we can always create our own ranges afterwards. So we've got 3-group range here. We could have been a 4-group range. So now if I go back to crosstabs, I can look at minority classification, and I'll ask for gender in there, broken down by current salary, which I'll put into the columns. We've still got a chi-square test here. We've still got row percentages switched on. I'll switch off the bar charts, click OK, I run that, and you can see here that we've got, first of all, the non-minorities saying that 28% of the non-minorities are on less than or equal to 25,000 compared to 35,000, 35%. 32% are between 25,000 and 33,000 compared to 50% of the minorities. Nearly 40% are over 33,000 compared to only 14% of the minority classification. This is regarded statistically significant because less than 0.05. And then for gender, we can see that for females, 57% of the females are on less than or equal to 25,000 compared to 7.4% of males. Conversely, 13% of females and over 33,000 compared to 50% of males. So we can really see, rather than just comparing the averages, where the actual inflection points are and where the differences are between these groups. Okay, one of the things that's kind of untypical of this particular data set here, which is a sort of HR survey, or a survey of employees, if you like, is that it doesn't have any rating scales in it. So rating scales are very common within surveys, and there are various ways in which we can work with them. I'll just show you an example of some rating scales here. Here's a little survey. This is a survey of an island. It's got 394 people in it. Each one of the people is a person on an island. They've got a different district. We've got questions about where they were born and their employment status and what industry they work in and what their age is and whether or not they regard themselves as healthy. And then we've got a typical bunch of rating scales at the end here, which we've called rate 1, rate 2, rate 3. And we don't really need to give them names for the fields headers at the top here, because they've all got variable labels, which is rate 1 relates to value for money, comfortable environment, courtesy of ferry staff, regularity of service, ferry cafeteria, facilities for small children, and journey time. So this is about people's rating of a ferry service to an island. And obviously we could go and analyze these. We could just say, okay, show me the frequency breakdown of this, so we can see that 28% of people say it's excellent value for money, 61% say good, only a very small number say poor or very poor. We've got some people here say don't know, or missing. That's very important in surveys. And within the SPSS, if you have missing values where people refuse to answer or they say it's not applicable, you can set these up as special codes. So you can see here it says -8 is not applicable. And that means it takes it out of the analysis, so it doesn't include them in the analysis. It keeps them separate from one another. So these wouldn't appear within things like crosstabs, as we'll see. If I do a crosstab here and I look at something like, facilities for small children, broken down by, let's say, marital status. It's a marital status there, we'll say. Again, that's the row percentages. Click OK. You can see of those never married, 74% say excellent, married 77%, widowed 70%, divorced 75%, and separated 70%. So there's not huge differences here between them, but the widowed people, 10% of them, even though there's only 2 of them, said that they thought facilities for small children was poor. And again, we can do statistical tests on that, but really, we've got this issue about, we can look at them individually. If we want to look at them all together, there are various things we can do. One of the typical things people do is that they treat these numbers as if they are, as if they're actual true numbers, not just rating scales, and they take an average across them. So one of the things we can do here is we can say, we can create a new field and we can call it mean rating. And I'll just give that an underscore there. And I can use a little function like mean. And I can use, I'm going to say rate 1 to rate 7. There you go. And that will just create a new column for me. And it tells me what their average rating is. You can see where the smaller the number, the closer they are to excellent. So a smaller number, closer they are to excellent. So that rating scale there just basically runs from, let's have a look, it runs from 1 to 4. So you could actually override it and say, well, I'm going to do it the opposite way. I'm going to reverse it and say, I'll take them all the way from 4. So if you get a rating of 0, that means, everybody said every answer to that question was poor, very poor, because they would all be scored 4. And you'd be taking 4 away from 4. So here you can say the larger the number, the better they think it is, and kind of reversing the scale. And then, of course, I can go and say, okay, let's look at the means table again. Let's say, let's look at the average mean rating broken down by, let's say, not place of birth. Let's have a district. There you go, electoral district 11. Click OK. See if there's any big differences. There aren't any big differences. You can see they're all about 2.1. There's a district here called Fortune Smiles. It's slightly higher, gives a slightly higher rating than and say this district here of Hartville, but they all look pretty similar to one another. So that's one way in which we can deal with rating scales. Another way we can deal with it is to use what's called a count command to say, I want to count how many times somebody says excellent, let's say, as a score of 1. So I can go to transform here and use what's called the count procedure. And the count values in cases just says, I'm just going to call it excellent. No, sorry, excellent count. And give it a label, say number of times excellent was ticked in the survey. And then all I got to do is pick up these rating scales and say, okay, I want you to count how many times. If you can't remember what this codes are, you can just right click here and say, okay, well the code is 1 for excellent. So you say, okay, I remember that. Count up all the ones and hit add, click continue, and okay. And that gives me a sort of excellent count. So you can see this person here has ticked excellent 6 times out of 7. And again, we could treat that as if it's a continuous field. So that's another way in which we can do that. And say, okay, that's also a continuous value. Now we click OK at that point, and it says, okay, well look, Fortune Smiles 2.3 on average excellence they get versus what's the smallest here? Hartville here 1.92. So again, not a huge number of differences, but another way in which we can combine many different rating scales that have the same scale under them together to summarize them within the data set and then compare them as if they were an overall scale. Okay, what about things like key driver analysis, satisfaction? Well, we're going to open up a different data set here. Here's another example of a survey. This is a HR survey where, let's see how many cases we've got. We've got 1,010 cases. And we've got, most of these are rating scales. So we could take rating scales here. Let's just see what the fields are looking at. If I just show you what the fields are looking at. So it's things like location of work. Do you rate location of work for 1 for very poor through to 5 for very good. And we've got things like provision of safety equipment, attitude of senior staff. And then we've got gender and IT, and we've got this kind of key field at the end. So this is where this sort of situation becomes very important. When you have something that says something like overall, how satisfied are you in a survey? That's very important because you can, there's certain techniques you can bring to bear which will give you the profile of people who are very satisfied versus not very satisfied. And here we've got this key field saying leaving. When will the employee leave? So they've asked them, how long do you think you'll stay with the organization in an anonymized survey? And some of them said, I'll leave within 2 years. Some say I'll leave after 2 to 5 years, and some people say remain at least 5 years. Okay, so that's kind of interesting. So is there a way we can do this? Well, there's various tools. There's actually a free tool on our website called the key driver analysis, which is kind of useful to play around with. The one I'm going to show you here is very visual. The key driver analysis produces a nice chart, but if you want to have a look at that tool, you can just download it. I'm going to do something called a decision tree. I'm going to try and get it to predict when will the employee leave. I'm going to pick up all these other fields here and pick up job type and throw that in. And I will just go and change a few little things here in the criteria. I'm going to let it down to a minimum number of 5 cases. This is easier when you actually run the routine. It's easier to explain what's happening once you've run the routine. You see the results of it, rather than the other way around. But here we have this weird little piece of output here, which is called the decision tree. And if I just open it up and then zoom into it, so I'll zoom to 100%. You can see I'm actually going to change some of the output here. So here we have blue is leave in 2 years, and green is remain at least 5 years. So if you're the company, you want everybody presumably to stay as long as possible. You want as many greens. But in terms of this decision tree, it's saying that anybody who says attitude of senior staff is less than or equal to fair. So if they say it's fair, not so good, then as you can see, 82% of those people say they will leave within 2 years. If they say it's kind of good, not 3 fair good, that means good, it means higher than fair but good, then it's kind of more evenly split here, where it's 37% say they'll leave 2 to 5 years. If they say it's better than good, then 74, nearly 75% say they'll remain at least 5 years. So there are 522 people in that group, people who say attitude of senior staff is better than good. And if we start to look at that 522 people, the algorithm breaks it down into the next most important field, which is working hours. And it says, if the working hours is good, then it's 78%, and if it say it's better than good, then 96% of them say they will remain at least 5 years. So basically, if they say the attitude of senior staff is better than good, and working hours is better than good, then 96% of them will remain. And if they say general environment is better than fair, then 99% of them will remain. So the point of the decision tree is to sort of act as a filtration device, separating one of the various categories within a key field, what's called a dependent or target field, from one to the next. And it builds a profile of people based upon the variables we put in there. It doesn't include a variable if it's not significant. So if we put in sign of the zodiac here, it doesn't include it. We put in the variable gender, and gender doesn't appear within the output because it's just not statistically significant. Things which are statistically significant are these various things that have been asked to rate. And this is very important because it's telling us off the rating scales, these are the most important factors which drive this output and this outcome. So that's good. So the other thing is it's basically a predictive model. So you can actually use this to predict outcomes. And here it's telling me the level of accuracy. It's very good at predicting leave within 2 years. It struggles with the sort of leave 2 to 5 years group. It's only 43% accurate there, but that's still pretty good. It's better than average. It's 113 in accurate predictive. And 90% of the remain at least 5 years. It's done 89%. It's very accurate on. So not only is it a good profile and a good way for us to profile data, but it's accurate as well. It's an accurate profile. If you were to apply this to a new data set, it would accurately classify them, which is one of the reasons why it's used in predictive modeling so often to predict whether or not people are going to accept an offer or not, for example. So we have an example of, kind of profiling people in terms of rating scales or in terms of categorical data. What about a couple of other examples here? So we've got some examples here. So we've looked at working with rating scales here, some rating scales here. We've looked at satisfaction prediction of key driver analysis, so we've looked at that. What about things like longitudinal analysis, where we're looking at survey data over time? Well, I've got one little example here. There's a famous book called Bowling Alone, and it was written by Robert Putnam. Putnam surveyed the decline of what he called social capital in the US since 1950, and he described this social capital in terms of the reduction of the various forms of social intercourse. In other words, whether or not people, engaged with one another, went out and went to dinner and that sort of stuff, or joined organizations. And he argued that this undermined active civil engagement, which a strong democracy requires, and made the data available for download. So there's lots of different questions within the questionnaire, and I downloaded the data from the questionnaire. If we just open it now, we've got this Bowling Alone data set here, and one of the things that's most interesting in it is we've got a lot of questions here about people's beliefs. So we've got questions about for example whether or not they believe in religion, or whether or not they believe in working hard. But there's also these questions here about whether or not they have trouble getting to sleep at night, or whether or not they feel they're under pressure. And because the survey has been repeated over time, it's gone from 1975 to 1998. So it's been repeated over and over again. So we've got this, basically, if you imagine this file, they've just added extra rows to it every time they've done the survey. They've just added extra rows to it and marked down which year it is that they've added to it. So if we wanted to compare one year to the next, a nice way to do that is to look at the average rating of these fields, to use something called error bars. Error bars are a way for us to show what's called the 95% confidence intervals in how reliable the fields are, how reliable the average is, basically. But if I do a little error bar here, I'm going to go to the bar chart and ask for error bars. I'm going to look at the year of the survey. I'm going to put that along the bottom. I'm going to color it by whether or not they're male or female. And I'm going to pick this field here. I feel I'm under pressure a great deal of time, where it goes from definitely disagree to definitely agree. And if I change that and say, okay, I'm going to treat this as a scale field and put that in there, and then run it, I'll just run it and then edit it, because it'll just use a little bit of editing. We'll just change the scale here. Look at it. We'll just go to scale here and say the minimum should be 2, so we can zoom into it a little bit. Hit close at that point. Exit. Make it a little bit bigger so we can all see it. So we can see here that the reds are the females, the blues are the males. That's just coincidental. And we can see that females in 1975 are much less likely to agree with this statement. And in fact, up to 79, they were sequentially declining in their agreement with the statement that I feel I'm under a great deal of pressure most of the time. The men were kind of averaging around but much higher than that. The fact that the bars don't overlap means that they're statistically significantly different from one another, because the two means, this is the 95% confidence intervals, means it's saying that if we were to repeat the sample 100 times, 95% of the time, the mean for the females would always be lower than the mean for the males. But then something starts to happen around about 1979. The female average response to this question starts to decline. And by about 1986, they're very closely overlapping with each other. And throughout the rest of the 1990s, if anything, the females on average are higher than the males, until eventually you get to 1998 and they're exactly the same as one another. The averages are exactly the same. So this is how a longitudinal survey is powerful. We could have used many, many other questions in there, like I have trouble getting to sleep at night. And it's a fascinating way for us to combine 3 different fields together to see how they're related. So it's a good example of treating the year field, treating the longitudinal marker. This is the field which indicates that it's a longitudinal survey. If we didn't have the year in there, we'd assume it was all, the data was all collected at the same time, and we might not see what's going on. But if we're collecting data over time, we can use this field which indicates when the data was collected or when the survey was sent out to help us see the trend, if you like, over time. Okay, so that's us working with pretty much quantitative data. What about when we're looking at open-ended responses? So open-ended responses are something that you often get in surveys, and they're usually neglected by people. People often do a lot with open-ended responses. So you get the questions like, is there anything else you'd like to say? Or, or you get other questions like, say, please tick what your attitude is to the following subject matter. And you often get an other. And then you get an author, please explain, so they get the opportunity to write in something. So here we have a survey that people have been asked about, their attitude to car hire. So they've all hired a car, they've been asked feedback on it, and they've written feedback on it. And we're going to use a tool now to try and analyze open-ended text responses themselves, rather than just listing them out or categorizing them by hand. We can jump out to a specialist tool, which is called IBM SPSS Text Analysis, Text Analytics for Surveys. Literally is about analyzing text data that's come from surveys. So if we open up a data set here, let's just see if I can find the data set here to open. Do I have a recent one? Okay. I'll just navigate towards it then. Okay, sorry, I'm being foolish. I haven't got, that's all, asked me to open a project. I'm going to start a new project. That's what I want to do, rather than open an old project. So I'll start a new project, and then I select the data source. You can see there's lots of different data sources one can read in. So I'm going to look for an SPSS file. Actually, I'm going to look for an Excel file. There's an Excel file there. There you go. Rental satisfaction. .xls. So that's the data file I'm going to read in. And it's got a little ID field, and it's got this field which is called contains the open-ended text, which is basically people's attitude to you know, their experience of hiring a car. And we get an opportunity here to use a third-party tool called Language Weaver to translate it into English in case it's not in English. But it is in English, so we don't need to do that. And at this stage, the final stage here, it's saying, do you want to use a resource template? And it turns out there's a bunch of different resource templates that come with the software for different reasons. You know, we've got one for customer satisfaction, we've got one for opinions here, we've got different languages. So we're just using the English language here, obviously. I'm just going to go with the vanilla one, just the basic one. So I'm just going to say, okay, I'll just go for the opinions. And you can see here at the background, you can see the actual text. What it's doing at the moment is it's reading that text and it's pulling out the terms, what it calls the terms of the text. It's basically separating the wheat from the chaff. This is being driven by a natural language processing engine. It's looking for phrases and topics and nouns that it deems to be, you know, at the heart of the text. So you get phrases like customer service. You can see when I click on customer service, it comes up here. And you get phrases like friendly, so it's being highlighted here. What's interesting is that when I click on phrases like fast, it's not just the word fast, it's looking for synonyms of fast. So it's looking for quick, quickly, fast, quickly. So it's actually, these are concepts that are related terms. So excellent here has the phrase outstanding, excellent, great, above and beyond. It knows in its dictionary behind here that these are synonyms of this. In the same sense, bad, you know, words atrocious, bad, badly. Sometimes it's going to get things wrong. Okay, and that's just how it is. And your job then is to correct that as you're going along. But really, using just the vanilla standard default settings here, we can see that it's actually pulling out a bunch of terms that are related to the car hire experience. And of course, one of the terms that comes out is car, okay, which would be related to automobile. And that's not terribly useful to us because we know it's about car hire. But we have got phrases here like good, we've got phrases here like customer service and friendly and fast. So that's kind of interesting. We wanted to categorize people and say, well, what are they talking about? We could just use this as an approach. We could say, okay, let's add that to a category and create a category from that. And we're going to create a category called friendly. I would take another one here and say it's a category here called fast and say we're talking about fast and speediness. There's a category here called problem. And say create a category for problems. And we've got a lot of categories here called, you know, things that don't too long. People it's taking too long, they're having to speed up, they have to wait in line. And you can see that the terms or the concepts here are color coded. And that's because they belong to a type. And the type, this sort of beige color here means that it belongs to an unknown type. So it doesn't know what customer service is. It knows that helpful is good. It knows that excellent is good. It knows that fast is good. It knows that too long is bad. It doesn't know what upgrade is. Just because it doesn't know what upgrade is doesn't mean you can't create a category of it. So I could say, I want to create a category of that. We've got a lot of stuff here related to price. And we've got a lot of stuff here related to waiting in line and waiting and not friendly and that sort of stuff. So we could actually create our own terms, our own types, if you like. Here's our own types here. So we could, for example, find here's one here, line, meaning a queue. And we could add that to a type and say, okay, I want to create a type and say a new type. So I say new, and I'm going to call it waiting. And I give it a little color-coded category. I'll call it dark red here. Generate inflected forms means waiting, you know, and inflections of wait. We click OK at that point. It goes that. Is there anything else I can add to that? So I could go into the dictionaries behind this. Here's the dictionaries behind this. Here's my new term here, waiting. And I could add other terms to that. And you can actually be surprised how many you can add to it. You can say, okay, wait. Waiting, time, something like that, queue, or queuing, you know, that type of stuff. What else can I say? Delay, you know, etc., etc. You get the idea. Click OK at that point. It's saying this term already exists as negative. Do you want to take it out as negative and put it in here? I'm saying yes. I want to take it out as negative, put it in there. I go back to it. It's all turned yellow in the background, meaning that it'll need to re-extract the data for that to take account of that. So it re-extracts that, and what we should find is a new type been created for us once it's done the extraction process. So it does this typing, and it does this extraction and grouping of the terms and the words together. We've got a type here. You know, somewhere down here we'll have a one called waiting or something. There's one called waiting there, and we could instead we could then add that to category. So we could put it into too long, or we could rename too long to waiting or delay or something like that. So this is one way in which we can very quickly create our own manual categories. Alternatively, it actually has its own categorization engine. So you can say I want to create categories and build categories, and there's various algorithms it's got for that. But if I just get it to build that, it will build a bunch of categories for me. So I'll let it do it, and then we'll rerun it again. We'll rerun the process again, but this time we'll use, so you can see there's lots of stuff here about reps and employees and people and returning and personnel. So what you do is you end up deleting a lot of these and merging them together until you're happy with the categorization process. If, however, I wanted to start again, say I want to start again, new project. This time I'm going to pick the same thing again, but I'm going to use an existing, perhaps more appropriate template that comes with it. So I click next. I can ask for a different resource template. I can ask for one which is customer satisfaction. There you go, customer satisfaction, English, hit finish. And this time, of course, it's got a whole bunch of terms that are, and types that are associated with customer satisfaction. So this time, when we run the process, it creates a slightly different categorization process. So it's typed the data in a slightly different way. So just let it do that for a second and see what new types and terms. So now we've got customer services. It's got its own type. We've got the types here. Look, there's one called customer support. So we can create a type for that. There's one already for wait time. See, it's been created for us. There's one for budget, which is just means anything to do with money. We've got stuff about negative functioning. We've got positive budget, when people are talking about budget in a nice way. Free, no charges, that type of stuff, etc., etc. And we could go into the categorization here and go into the build categories and edit it and say, okay, well, I want to do it based on types and go into advanced settings here and choose, I don't know, some sort of method here and say save and close and build categories based on that. And it would add extra. There's one called rental here. See, I don't think rental is very useful, so I would probably just get rid of it because it's about car. I'd get rid of that. But the other ones are quite useful because we've got stuff about, you know, airport here, upgrade, counter, check-in, insurance. And that's all kind of useful. So you can imagine how doing a few passes of this data, you eventually end up with a categorization schema that you're happy with, and you categorize most of your data. You can then save that, export that categorization as what's called a TAP. So you can write it, turn it into a text analytics package. And of course, I've already got one. So if I go here and say new project again, I should have one here anyway. Let's have a little look. Hit XLS. There we go. Rental satisfaction. Just go through the process again, and we'll see one that I've already created. And say text analytics package load. Do I have one? I might have one here. I've got employee satisfaction. I've got brand awareness. I may have one in this tool here. So I just go down to smart 7 hours. Just give me a second. Well, I think it's because I've got this highlighted already. Oh, I'll go one. There we go. There we go. Just navigate through it. So let's go to this PC, D drive, see demos, find this webinars. Oh, I don't have it in there. Okay, don't worry about it. Okay, well, a TAP package. Let's see if we can find one that will go back to sample files here. Fine. Tap. Okay, we'll just choose one. We'll just use customer satisfaction tap and say, okay, that's the one I want. So this is mixed opinions. Click load to get the idea of it. Hit finish. And the difference here is that if you've already got a tap, you've already created one, you can see that it creates these categories for you. So it creates these categories for you. It types the data. It puts the data into the categories for you and tells you how many cases it's successfully done that with. And then once it's categorized the data, you can export that data as a file. So here it is. You can see these are a number of cases that's going into satisfaction, don't know, product functioning, pricing and billing, but price too high. You can see these are the categories that people belong to. So I can then go and say, okay, now I want you to, export the results as let's say an SPSS statistics file, and that creates a file a little like this. So if I just jump back to SPSS statistics and open up a file, and if I look at this one here where we've got car rental multiple response, there you go. These are the things that the TAP file that I was trying to find has in it. So you got things like collection and drop off, negative characteristics, whether people are talking about air travel or positive characteristics, positive pricing, and they're just trues or falses. Just did they belong to this? Sometimes people just say no problem. So if I want to analyze that, I'm going from the open-ended responses into the quantitative worlds, from unstructured to structured data, and I could go to analyze tables, custom tables here. And I've already grouped these together. I've already defined these as what's called a multiple response set, and there they all are. And I can go into summary statistics and say, okay, well, I want this to show me column percentages, count, and if I go down here to multiple response and go to column responses, basically, if we click apply at that and then close, if I go into categories and totals and sort it in terms of count order descending, you'll get two different sorts of percentages coming out. So I could relabel these, of course. This percentage here is the percentage of times that comes up across the survey. So it's the percentage of records, really. So percent of records or surveys returned. So we're saying that basically 64% of the surveys returned mentioned positive customer service, 19% of them mentioned wait times, nearly 19% of them mentioned negative customer service, 17% mentioned negative characteristics, 13% said no problem, 10% said upgrade. But off the responses, this is percentage responses really, or percentage ticks if you like. Let's call it percentage of topics, let's say. That's the easiest way to describe it. Then we're saying that of all the topics that are mentioned, positive customer service is mentioned 37% of the time, wait times mentioned 11% of the time, negative customer service 11% of the time. So we've kind of closed the loop there and gone from from open-ended responses to unstructured data to structured data. We've categorized it and classified it and turned it into a data file where each of the topics that was categorized is turned into a binary field, and we have then run a particular procedure to find them as a multiple response set, run a particular procedure on that, and squirted them out as a multiple response set table. So multiple response questions, of course, don't have to come from open-ended responses. You should actually have them in the survey, and that's how they're encoded, and that's how we present them within an SPSS. So you could have any one of these. Please tick any question where it says please tick all that apply, or if they can tick more than one answer, that's a multiple response question. So advice to get started, you have to, when you're analyzing survey data, you should really focus on why the feedback or survey data is being sought in the first place. What's it for? Because that's going to give you an idea of what you should be looking for when you're analyzing the data. Don't be frightened of open-ended questions. You should consider text analytics for open-ended questions or feedback. It is an easy way to categorize them. It's quite powerful. You can actually use syntax to automate the analysis for regular reports. So within SPSS, for example, instead of clicking OK to run a routine, you can click paste and it will show you the syntax. So if you're running regular reports, again and again, you can run a syntax job which will automatically go and grab the data for you, format it, clean it, and punch out the report for you. It's very easy to do. Highlight statistically significant relationships. There's lots of different ways, lots of different statistical tests you can do that. You saw me doing one with chi-square. Think about ways of combining rating scales. There we had the count procedure and taking an average. Consider if you could predict outcomes. So there we were using decision trees to predict an outcome, such as what satisfaction or how long somebody was likely to remain an employee. And look for opportunities to combine survey or feedback data with other sources, such as CRM data or information about how they're actually using a service, or their tenure, if you know who the customer is, because this can be shown to be very, very powerful and add an extra dimension to analytics. With regard to working with us, well, we provide the software that you've seen here today. So you can buy that directly from us, and we also provide training and consultancy service, and that includes side-by-side consulting, skills transfer, classroom training, as well as identification and recruitment of analytical skills into your organization. We offer no strings attached advice, and we're also a technical support providing partner to SPSS and SAS. I do hope you find that useful. We have a number of other webinars coming up over the course of the 2018, usually once a month. So do feel free to register for some other ones. It's not quite the weekend yet, but it will be soon. So I do hope you have a good weekend, and we do look forward to you logging in again at some point in the future. Thank you very much.